So write this down for reference angles. Write that down for reference angles. There we go. That's a pretty good definition of reference angles. Let's take a look at some actual examples here. Just look at part A. Don't look at part B yet. Think about the definition. The definition is the difference between the terminal side and the x-axis. So what is this little gap right in here? That's the reference angle. So what is it? What's the difference between the ending of this angle, the terminal side, and 180 degrees? This is 130 right here. That's 50 degrees, right? Reference angles are always in relation to the x-axis, never ever in relation to a y-axis. But here's how I want you to answer this on your worksheet. The original angle we'll call theta. So if theta equals 130, this is the symbol for a reference angle. It's theta with a little mark above it, like an apostrophe or something. It stands for prime. This is called theta prime. That's reference angle. So what's the reference angle? 50. Yep, 50 degrees. So take a look at number 1 on your worksheet that I just handed you. If theta is 170 degrees, then what's the difference between that and 180? 10. So the reference angle, theta prime, equals 10. Yeah, I'd like you to write it as theta prime. Just so we're both clear, we're all clear that you're talking about the reference angle. Okay, don't go on to number 2 on your worksheet. Let's go back here to part B. Think about the definition. It's the difference between the terminal side and which axis? X-axis. Okay, you're never ever going to try to find a reference angle by drawing something to a y-axis. Always to the x-axis. Tell me what this problem is, though. Is this the reference angle right here? It has to be less than 90, so if you try to say that this is the reference angle, that's way bigger than 90 degrees, so that can't be the reference angle. It has to be the difference to the nearest x-axis. This is the nearest x-axis. What's the difference between 180 and 200? 20. Okay. This is 180. If the original angle is 200, the difference between 180 and 200 is 20 degrees. Reference angles are always positive. So theta is 200 degrees, which means theta prime is 20 degrees. Theta prime. Autobots assemble. It does kind of, huh? What about 290? It is possible to do this without drawing, but if you want to draw this angle, especially when you're learning this, it might be useful to draw the angle. Or Or you just got to think which quadrant is that in. Maybe that'll help. Which quadrant is 290 in? It's in the fourth. Yeah, it's in the fourth quadrant. So you're not going to backtrack and go back up to 180. You're going to go. Here's what I mean. 290 is about right here. That's 290 degrees. Now, are you going to go backwards and try to find this distance to the x-axis? No, that would be bigger than 90 degrees. What about this little piece inside of here? That's drawn to the y-axis. That's incorrect. Reference angles always have to do the x-axis, so we're looking for this piece right here. What completes that? 70 degrees. Because what is it all the way around a circle? 360. If you've already gone 290, what's the difference here? 70 degrees. So the reference angle is 70 degrees. Now what? Yeah. On part B, well, the original angle was, maybe it's hard to read. The original angle was 200 degrees. Oh, yeah, it's a 200 there. Now look at number 2 on your worksheet. What's the difference there on number 2? Is it still an angle? It's still an angle, right? It's just in radians. So let's talk about, here's part D. What if it's in radians? That's what most students prefer to do. I think most students are more comfortable in degrees, and that's fine. It's not that one's better than the other, really. Would you guys feel more comfortable looking at this in degrees? So how do we convert it to degrees? Yep. Now, okay. Why does pi have to be on the bottom? Yeah. Good. Cancels with the pi on the top over here. 4 times 180 is 720 divided by 5. Yeah, good. So the original angle theta is 144 degrees. We need to now find the reference angle for 144 degrees. Theta prime. What is it? 36. Now listen carefully, you guys. You need to realize this just so you can get more points on a test. What unit of measure did we start with? Degrees or radians? Look at what we started with. So we need to end up in that same unit of measure. 36 degrees, it is the correct reference angle, but you wouldn't get full points because you don't end in the same unit. So what should you now do with 36 degrees? Switch it back into radians. Okay. So in radians, 36 degrees in radians, that's the answer we're looking for. You'd get most of the points if you answered 36 degrees, but I'm not going to give you full credit because you started in radians. You have to end in radians. So you times it by pi over 180. Yep, that's right. And what do you get? 36 pi over 180, and then 36 divided by 180. Needs to be a fraction. Exactly. 1 pi over 5. Or you could just say pi over 5. Now, I'm going to show you a different way that some students just can't. They don't like it, number one, because they don't understand fractions very well. If you're comfortable with fractions, this way is faster, much faster than having to go from degrees back into radians. It takes, I think it takes way too much time to have to go into degrees and then into radians. So this is worth listening to. You don't necessarily have to write this down, but take a look up at the screen. Okay, stop working on your worksheet because this will save you time if you can understand fractions. How many radians is it to start here and end here? Remember, all the way around a unit circle is 2 pi, so if you're just doing half, it's just pi, right? 1 pi. Does that make sense, first of all? Because didn't we just talk about that 180 degrees is the same as what? Pi radians. We talked about that last time. 180 degrees is the same as pi radians. Are we okay? We okay with that at least? Pi radians is the same as 180 degrees. Now, you guys understand how 1 works. Is this the same? 2 pi over 2 isn't the same as 1 pi? Or isn't the same as 11 pi over 11? Couldn't 1 be anything, really? So here's the thing. 4 pi over 5 is about right here. This is 4 pi over 5. The reason I know that it doesn't go beyond pi, if you were to type in 4/5, is that a value that's greater than 1 or less than 1? 4/5 is less than 1. That's why I know it doesn't go all the way past pi. So what's the difference between 4 pi over 5? And I'm going to change 1 pi into this, 5 pi over 5. Why do you think it's important that you have 5s on the bottom? Common denominator. What's the difference between 4 pi over 5 and 5 pi over 5? 1 pi over 5. Okay, so it is not necessary to go into degrees and then back into radians if you understand how fractions work. Okay, or let me show you a different one. What if the angle were 6 pi fifths? Now, how do you know if that's beyond 1 pi or not beyond 1 pi? What's the value of 6 pi over 5? Or what's the value of 6/5? Is it greater than 1 or less than 1? So it's beyond 1 pi, isn't it? So if this is 1 pi, or to make it easier, what if this is 5 pi over 5? What's the difference between 6 pi over 5 and 5 pi over 5? 1 pi over 5. So the reference angle will be 1 pi over 5. So if you understand how to work with fractions, reference angles in radians can go pretty quick. For example, question number 2 on your worksheet. They drew it out for you. 13 pi over 9 13 pi over 9 is right here. Isn't that what it says on your worksheet? Now you could convert this into degrees. That's fine if you want to do it this way. It's not a problem. I think it's 260 degrees. And then what's the reference angle? If this is 260 and this right here is 180, what's the difference here? That's this distance here to the y-axis. We want this distance. Between 180 and 260 is what? 80 degrees. So the reference angle theta prime is 80 degrees, but you'd have to convert that back into radians, and it's 4 pi over 9 if you want to go that route. Okay? Or, you know that 180 degrees is the same as 1 pi, or you could think of that as 9 pi over 9. What's the difference between 9 pi over 9 and 13 pi over 9? 4 pi over 9. Okay? It's just learning how to deal with fractions. So take a minute, do a couple of these, 1 through 6 only. Don't go on to number 7. So try a couple of these, 1 through 6. Okay, something I want you to do, and make sure that you are very clear on this in your notes. Whenever you see the phrase find the exact value on your test, this is what it means. No calculator. Okay, find the exact value. These have to be done by hand. You can use your calculator to check your work. Find the exact value means this is going to be something you do without a calculator. So make sure that's clear in your notes. Okay, now some of these your calculator might be useful for. Like if you have a calculator, type in the sine of 30, hit enter. It's 0.5. Now that's an exact answer. 1/2, that's exact. The problem is, type in the sine of 60. Or type in the sine of 45. Are those exact answers? No. So exact answers have to be done without a calculator because your calculator does not give you exact answers. It gives you decimal approximations. Now, think back to 10.1, the assignment we did last week before the term ended. We found sine and cosine and tangent on what shapes? What type of triangles? Right triangles. That's what we're going to do here. We're going to have to find the sine of 30 using a right triangle that has 30 degrees as part of its angle measure. Does this sound like a triangle we might know? 3069. That's why we brought it up at the beginning. So 3069 is going to be pretty useful here. It's a pretty nice looking triangle, isn't it? You're not going to make me feel bad. This is a perfect triangle. $30, $60. It's not the angle measures that make this a special triangle. It's the measures of the sides. Okay. Unfortunately, there's no easy way to remember this other than just looking at this long enough and studying it long enough that you remember.
Mr. Huff?
Yeah.
Did Brooklyn shock me in class?
Yes.
Okay, will you send her to the attendance office? She's being checked out.
Okay.
Thank you.
Yeah. So you need to remember the length of the sides, you guys, and this is the easiest way that I can think of to remember. You did learn in geometry that the smallest length is opposite the smallest angle. Did you guys learn that? Okay. What's the smallest whole number you can think of? 1. So let's make that 1. Opposite 30 degrees is always going to be 1. I don't expect you to remember much else about the 30, 60, 90 because it's been a while, but the hypotenuse is always double the smaller side. So what does this have to be? 2. Okay. The hypotenuse is always double the smaller side. Across from 60 degrees is always going to be square root of 3. You could have found that using Pythagorean's theorem, but we just don't have time. You need to remember 1, 2, square root of 3. Those are the sides of the 30, 60, 90. Now, why is this triangle so useful? Now, could we do the exact value of the sine of 30? What's the definition of sine? What over what? Opposite over hypotenuse. So look at the 30 degrees. What's the opposite side? And the hypotenuse is 2. Now, I also had you type into your calculator the sine of 60, and it gave you something like 0.86, I think. 0.866. That's not an exact answer. So let's see if we can get the exact answer off of this triangle. What's the sine of 60 degrees? The square root of 3 is the opposite side. What's the hypotenuse? 2. Now, there is a way to use your calculator to check your work. The sine of 60 was 0.866, right? Type in the square root of 3 and divide it by 2 and see if that gives you the same decimal. If it does, then we just checked your answer. Is it the same? That's a habit you ought to get into, is checking your work. What about this one? Cosine of 30. What if I asked you to do the cosine of 30? What's the definition of cosine? Adjacent. What's the adjacent side for 30 degrees? Square root of 3 over 2. So the cosine of 30 is the square root of 3 over 2. These we're all figuring out without a calculator. Okay. We could do tangent, but we just don't have time. We'll skip tangent. You guys remember the definition of tangent, though. What's tangent? Opposite over adjacent. Good. Now, these two angles specifically, 30 degrees and 60 degrees, those are considered special angles because we can figure this out without a calculator. 30, 60, and 90, I guess. There's one more angle that will work that we can figure out without a calculator. It's the 45, 45, 90 triangle. So draw this one. It would be in your best interest to have this as exact as you can in your notes so you can use it next time on your quiz. This I hope a lot of you remember. What's it called when a triangle has two equal sides like this? Starts with an I, isosceles. A 45-45 triangle is isosceles. These two sides here are always going to have the same measure. This side has a length of 1, this side has a length of 1, so using Pythagorean's theorem you could figure out this is the square root of 2. So 45 degrees is the other special angle that you can figure out without a calculator. For example, if I asked you the sine of 45, if you were to type that into your calculator, somebody try it real quick. It's like 0.70. What is the sine of 45? 0.707? Okay. So that's not an exact answer. It doesn't matter which 45-degree angle you use for this one because these sides are the same. The opposite and the adjacent are the same. So what is the sine of 45 degrees? 1 over square root of 2. Does anybody see a problem with this answer? Square root's on the bottom, so I know it's been a while, but we have learned what to do. Times by the square root of 2, yep. Times by the square root of 2 on the top. Good, you guys remember. So the final answer would be square root of 2 over 2. Yep, the sine of 45 is the exact same as the cosine of 45, yep. The tangent, yeah, that's an interesting question. The tangent of 45 degrees is 1 over 1. So, whoa, hello. Yeah, the tangent of 45 is always going to be 1. These are called the special angles. You can figure all these out without using calculators. You can check your work, but other than that, you have to do this by hand. Now, why did we just learn about reference angles? Here's why. And we only have about 10 minutes left, so. Remember, find the exact value means no calculator, but 120 degrees wasn't part of one of those triangles, one of those 30, 60, 90, or 45. But reference angles will help greatly. Write this as a note in your notes. A note in your notes, that's kind of redundant. Sine of an angle is the same as sine of theta prime. What does it mean, theta prime? Reference angle. So the sine of an angle would be the same as the sine of its reference angle, or cosine or tangent for that matter. Now this is 99% accurate, what I've just written here. Sometimes if you take the sine of a reference angle, your answer turns negative, when here it would have been positive. So, and I'll explain why, and I'll show you why in just a second. But for now, 120 degrees is in which quadrant? Second? Right about here. This is 120 degrees. Do you guys agree? Now, some of you have been whispering the reference angle. What's the reference angle for 120 degrees? So this little angle down here is 60. You guys agree? So now look what we can do, and I would recommend you guys do this. Draw a line straight down to the x-axis. It's very important that you do this to the x-axis, because that's where reference angles are drawn to the x-axis. Now look at what we formed. If this is 90 and this is 60, what's the angle up top? 30. And now we just got to remember, how do we fill in the sides? What's the hypotenuse? Remember, the hypotenuse is 2. Now this is why sometimes your answers go negative instead of positive. Think about this graphically. If you start at the origin and move to the left, what direction is that? Negative. This is opposite 30 degrees, but instead of calling this positive 1, we need to call this negative 1, because we moved a direction of negative 1 units. And since we're moving up, that's going to be positive square root of 3. The hypotenuse, regardless of where it is, the hypotenuse is always positive. You're going to need to remember that. Hypotenuse is always positive. Now anyway, what's the sine of 120 degrees? We need to consider the sine of its reference angle, because it's going to be the same thing. So look at its reference angle. What's the sine of that reference angle? What's the definition of sine? Opposite over hypotenuse. So the sine of 120 is square root of 3 over 2. Is there a way to check that on your calculator? Type in sine of 120. Quick, go. What's the sine of 120? Should be 0.86, and then type in square root of 3 over 2. 0.86. Here's why it's so essential that you include negatives when they're supposed to be negative. What if we did the cosine of this exact same angle, the cosine of 120? What's the reference angle for 120? 60. So we need to do the cosine of this reference angle. But what's the adjacent side to this reference angle right here? What is it? Negative 1, and the hypotenuse is 2. So the cosine of 120 is negative 1/2. Because the adjacent side, we've started at the origin and moved to the left, that's a negative value. So the cosine of 120 is negative 1/2. Let's try this one. Cosine of 210. Be as diligent as you can about writing these notes, you guys. I know the class is about to end and you've been here a while, but don't zone out. Focus here. Where is 210 degrees? What quadrant? Third quadrant. 210 degrees is about right here. What's the reference angle for 210? 30, yep. Because this is 180 right here, this is 210. The difference of those angles is 30 degrees. Now if we draw that side of the triangle straight back to the x-axis, we formed another 30, 60, 90 triangle. The part students struggle with the most is knowing how to label this triangle. I think it's always easiest to start with a 30-degree angle and go opposite, because what's that side always going to be? 1. But in this case, we're moving down negative 1. The hypotenuse always has to be a positive value, regardless of where it is. So we're going to call that positive 2. And what's the other side across from 60 degrees? It is a square root of 3, but since we're moving to the left, it's negative square root of 3. Now the other thing I've seen students make a mistake is, which cosine angle are we going to do? 30 degrees or 60 degrees? Which one is really the reference angle here? 30 degrees is the reference angle, so that's what you take the cosine of. What's the cosine of 30 on this particular triangle for 30, 60, 90? What's the adjacent side? Negative square root of 3 over 2. Let's do 1 or 2 off of your worksheet. Turn to number 7. Did they draw it for you already? Okay, 240. They're measuring it this way, so this is, or sorry, negative 240. That's negative 240 degrees. What's the reference angle? 60. So this is a 60-degree angle between that terminal side and the x-axis. That's 60 degrees. That's a 60-degree reference angle, isn't it? Now, if you form a right triangle out of that, the top angle is 30. So what's across from the 30-degree angle on this triangle? Negative 1. We're going to call this negative 1 because we're moving from the origin into the left direction. Hypotenuse is positive, and it's positive too. Hypotenuse is always positive. And this side is the square root of 3. So instead of taking the tangent of negative 240, let's talk about the tangent of its reference angle, 60 degrees. What's the definition of tangent? Remember, SOHCAHTOA. So it's opposite over adjacent. What does it mean to divide something by negative 1? Like, what's 5 divided by negative 1? It's negative 5, right? So the square root of 3 divided by negative 1 is really just what? Negative square root of 3. Yeah, we got about a minute and a half. That's time to do one more. Let's do number 9. $225 degrees. And I want the cosine of that. Whoa. Okay, we better hustle here. What's the reference angle for 225? 45, correct. 45 degrees. How do we label a 45, 45, 90 triangle? It's 1, 1 squared root of 2, but since we're in the third quadrant, this has to be negative 1, this has to be negative 1. The hypotenuse is going to remain positive. And we have to do the cosine of the reference angle, which is that 45-degree angle. So it's going to be adjacent over hypotenuse. What's the adjacent length? Negative 1. Hypotenuse. Square root of 2. All right, you guys can finish it. It's not done yet, but it's negative square root of 2 over 2. Yeah.